Imagine a mountain so tall, its peak pierces directly into the void of outer space. Mount Everest, the roof of Earth, looks like a minor hill next to this giant. This is Olympus Mons, the largest supervolcano ever recorded in the solar system. How was Mars able to forge such a monster of planetary geology?
And what would happen if this cosmic leviathan appeared right here on Earth?
Welcome back to our journey through planetary geology. Today, we dive into a battle of epic scale: Earth volcanoes versus Olympus Mons. The numbers you are about to see will completely reshape your perspective on nature.
Fasten your seatbelts. Our journey begins right now.
Don't forget to subscribe so you never miss out on the greatest mysteries of the universe.
When we think of giant volcanoes on Earth, Mauna Kea in Hawaii immediately comes to mind. Measured from its base deep beneath the ocean floor, Mauna Kea stands at 10.2 kilometers. When measuring purely above sea level, Everest holds the crown at 8,848 meters.
But turn your gaze to Mars. Olympus Mons soars to an incredible 21.9 kilometers.
That is nearly 2.5 times the total height of Mauna Kea, and nearly 3 times Mount Everest. The summit of Olympus Mons actually extends above most of Mars's thin atmosphere. If you stood on its summit, you would be staring directly into the blackness of space during daytime.
Yet, the staggering scale of Olympus Mons goes far beyond its vertical height.
Its base spans 600 kilometers across, an area equivalent to the entire nation of France. Because it is a shield volcano, its slope is extremely gentle, averaging only 5 degrees. If you were walking up this mountain, you wouldn't even realize you were climbing a slope. At the top sits a massive caldera complex, a sunken crater 80 kilometers wide.
This volcanic bowl could comfortably swallow whole megacities like Greater London.
On Earth, the largest shield volcano footprint belongs to Tamu Massif beneath the Pacific. Yet the total volume of Olympus Mons is roughly 10 times larger than Tamu Massif.
This massive volume differential is proof of Mars' unique geological potential.
So how did a planet much smaller than Earth construct a mountain so much larger?
The secret lies buried deep within the interior engines of both worlds.
It boils down to 2 key factors: plate tectonics and gravity.
Let's break down these planetary mechanisms step by step.
Earth's outer crust is fractured into tectonic plates that constantly move. As a plate moves over a magma hotspot, it creates an island chain, like Hawaii. Each volcano only receives magma for a few million years before drifting away. Mars, however, lacks mobile tectonic plates. Its crust remains completely stationary. Lava erupted over the exact same spot continuously for billions of years. Layer upon layer of cooling lava stacked up, pushing the summit higher and higher. The second critical catalyst is planetary gravity. Earth's strong gravity of 9.8 meters square head weighs down and limits how tall mountains can grow.
Martian gravity is only 38% of Earth's, allowing rock structures to support far more mass.
The rigid Martian lithosphere supported this enormous load without buckling underneath.
Furthermore, the chemical composition of the lava played a major role.
Martian lava is rich in iron, making it highly fluid and able to flow across immense distances. This explains why the volcano has such a wide footprint, yet an extremely shallow slope.
These four factors combine to turn Mars into the master architect of the solar system. If Earth tried to build a mountain this large, the crust would simply collapse beneath it. Only Mars' unique combination of deep mantle plumes and low gravity made this possible. Olympus Mons is not alone. It is part of the massive Tharsis volcanic province.
The Tharsis bulge is so massive that it actually altered the rotational axis of Mars.
Circling its perimeter is a sheer cliff drop known as the Basal Escarpment, 6 kilometers high. Now, let's imagine a terrifying scenario. What if we brought this monster to Earth? Imagine dropping Olympus Mons right into the heart of Western Europe. It would engulf all of France, Switzerland, and stretch past the German border.
If placed in North America, its footprint would crush the entire state of New Mexico.
Commercial jetliners fly at cruising altitudes of 10 to 11 kilometers.
That means an airplane would slam straight into the mountain wall halfway up. This mountain would violently disrupt global atmospheric convection and jet streams.
It would block weather systems, turning half a continent into desert and the other into superstorms. Earth's crust would buckle beneath its weight, triggering planetary megaquakes. And if this supervolcano were to erupt on Earth today? Ejected ash plumes would completely block out sunlight across the globe for decades. Earth would immediately plunge into a catastrophic volcanic winter, devastating life.
Ultra-fluid lava flows would sweep across thousands of square miles at relentless speeds. Seismic shock waves would reverberate through Earth's core, triggering secondary eruptions worldwide. Even famous supervolcanoes like Yellowstone would be a drop in the ocean by comparison.
Fortunately, this silent giant rests safely on the desolate surface of Mars, where its thin atmosphere poses no threat to a thriving biosphere. Yet behind this peaceful exterior lies a fundamental planetary question. Is Olympus Mons truly dead? Or is it merely resting between eruptions? Recent orbital scans from space agencies have revealed surprising clues. Let's examine the true age of these solidified lava channels. For a long time, scientists assumed Mars was geologically dead. By counting impact crater density, researchers can date planetary surfaces. The fewer impact craters a region has, the younger its volcanic surface is. ESA's Mars Express probe found lava flows on Olympus Mons that are only 2 million years old. On a planetary timescale of 4.5 billion years, 2 million years is practically yesterday.
This means when early human ancestors walked Earth, Olympus Mons was likely still erupting. Thermal modeling suggests that pockets of heat still persist deep within the Martian interior. NASA's InSight lander recorded numerous Marsquakes originating near the Tharsis region.
This proves that molten rock and magma dynamics under Mars are far from dormant.
Subterranean lava tubes inside Olympus Mons could become habitats for future human colonies.
Thick basalt walls would shield pioneers from harsh cosmic radiation and extreme temperatures. Deep within its high-altitude caldera, scientists suspect trapped water ice deposits exist. Olympus Mons could transform from a terrifying geological wonder into a launch pad into the cosmos.
Launching rockets from a 22-kilometer summit bypasses 90% of atmospheric drag.
It is the single best location in the solar system to anchor a future space elevator.
Comparing Earth's volcanoes with Mars showcases the stunning diversity of planetary evolution.
One world constantly recycles its surface. The other preserves its ancient history in grand scale. Olympus Mons is more than a mountain. It is a monument to cosmic geological history.
Standing at its base will eventually mark one of humanity's greatest milestones. And that is the true story behind the greatest geological giant ever discovered.
In summary, while Earth's volcanoes are dynamic and ever-changing, Olympus Mons stands as an eternal monument.
Earth gives us life through active plate tectonics. Mars gives us a masterclass in cosmic scale.
Which stat impressed you most about Olympus Mons? Its height, its footprint, or its 6-kilometer cliffs? Drop your thoughts in the comments section below and join the discussion. If you enjoyed this breakdown, give us a like and hit subscribe to support the channel. Click on the next videos appearing on screen to continue exploring the mysteries of the universe.
Thank you for watching, and we will see you in the next episode.
Space science. Unlocking the frontiers of human knowledge. Channel name: Journeying Together to the Stars.